So the question we are looking at is the queuing theory, and we have the question here, and the question says below is an extract from the operation records on the BLK company, a third-party logistics company. So under the table we have the activity, and then we have the number of loading teams working per shift, and then we have a average number of trucks arriving, and in each number of teams we have 8 ships, and then the average time each truck waits to be unloaded. If it's unloaded by one team, it will take 8 hours. If it's unloaded by 2 teams, it will take 5 hours. If it's unloaded by 3 teams, it will take 4 hours, and if it's unloaded by 4 teams, it will take 3 hours. And then we have total truck hours lost per shift, which we are supposed to calculate, and it represented by value A, B, C, D. And then we have estimated cost per hour of idle truck time, and for every idle truck time it costs 2,000. And then we have to calculate the value of trucks lost time or waiting costs. Yes, so the value is EFGH. Also of loading team's salary or service cost. So if we take a team one team, it will cost 4,500. 2 teams, it will cost 9,000. 3 teams, it will cost 13,500, and 4 teams, it will cost 18,000. And then we are supposed to calculate the total expected cost, represented by value J, K, L, and M. So normally for these kind of questions, all your calculations will come from the values you are required to get. Yes, so you can create a table, or you can draft out the way to calculate the unknown values, which we have A, B, C, D, E, F, G, H, and then we have J, K, L, and M. Yes, so to calculate for A, B, C, D, that is the row of total truck hours lost per shift. So how do you get the total hours truck hours lost per shift? The formula is average time to unload each truck times total truck hours lost per shift. And to get that, we'll take the value from the second row times the value in the first row. Yes, so for example, if you are looking for the total truck hours lost per shift for value of A, it means we'll take the value in the second row times the value in the first row. Yeah, so the value of A will be equal to 8 times 8. So to get A, it will be equal to 8 times 8, which will be equal to 64. And the value of B, it will be equal to 8 times 5. So it will be equal to 8 times 5, which is equals to 40. And remember, these are total hours, so your value will be in hours. The value of C will be equal to 8 times 4. 8 times 4, which is equal to 32 hours. And then the value of D will be equal to 8 times 3. 8 times 3, you get 24 hours. So the easy way for this particular question to get the values of row 3, you take the value of row 2 multiply by the value of row 1. Value of row 2 multiply by the value of row 1 to get row 3. Yes, then to get the value of row 5, which is the value of truck lost time or waiting cost, the formula is total truck hours lost per shift times estimated cost per hour of idle truck time. Yes, and this value you get them from row 3 and row 4. Row 3 and row 4. But remember, you've already calculated for the values in row 3, which is A, B, C, and D, as you're seeing here. Yes, so to get the value of E, F, G, and H, it means you take these values here times these values here. So if we're calculating for E, because we already know the formula, our value for E will be equal to A, which is 64 times the estimated cost per hour, which is 2,000. That will be equal to 128,000, and the cost is in cedis. To get the value for F, the same procedure. It will be B times 2,000, and the value for B, we already have it, is 40. So it will be equal to 40 times 2,000, which is 80,000. To get the value for G, the same thing, C times 2,000, and the value of C, we already have it, is 32. So it will be 32 times 2,000, which will give us 64,000 cedis. Then to get the value of H, the same thing, D times 2,000. The value of D, we already have it, is 24. So it will be 24 times 2,000, which will give us 48,000 cedis. So you already have the value of EFG. Yes, so any question that come across or involve this value, you'll be able to do it. And last but not least, we have to calculate for the value of J, K, L, and M, which is the last row. It's the last row, yes. So the last row represents the total expected cost, and as we know, the total expected cost is equal to waiting cost plus service cost. Yes, so from our table is equal to offloading team salary of service cost plus the value of tracks lost time or waiting cost. So this value, we obtain them from the row 6 and row 5. So to get the total expected cost, which is row 7, is equal to row 6 plus row 5. But remember, you've calculated for the values of row 5 already. So to get the value of J here, to get the value of J, it means it will be E plus 4,500. E plus 4,500. But we have the value of E already, which was 128,000 cedis. So it will be 128,000 cedis plus 4,500, and that will give us 132,500 cedis, right? Then for the value of K, it will be F plus 9,000, will be equal to 80,000 plus 9,000, which is 89,000 cedis. And then for value L, the same thing, it will be G plus 13,500, and the value of G we have here is 64,000. So it will be 64,000 plus 13,500, and that will give us 77,500 cedis as a value of L. And lastly, the value of M. You already know H plus 18,000. So the value of H, we already have it, is 48,000 plus 18,000, which will give us 66,000 cedis. So from that point, we already have the value of A up to M. So all our calculation will base on these figures here. Yeah, so let's go to our calculation and see how the question are. So the first question is saying, what is the value of A? And we already know the value of A was 64. So our answer is, for question 1, our answer is A. Then for question 2 is saying find the value of B. The value of B, we had 40 hours, and the 40 hours is B. So for question 2, our answer is B. For question 3 is saying the value of trucks lost time for one offloading team given 2,000 cedis per hour idle time cost is. So here we're supposed to find the value of trucks lost time for one offloading team, and we already solved it. That is the value of E. Value of truck lost time is E. So E, we calculated it already, was 128,000, and 128,000 is option A. So 3 is A. Yeah, so question 4 says for 3 offloading teams, what is the value of trucks lost time? So we are looking at the value of trucks lost time. So for 3 teams, it was value G. For 3 teams, it was value G, and we already calculated for value G, and G is 64,000. So back to the question, 64,000 is option A. Then 5 is straight, is saying what is the value of M? We already have it. The value of M was 66,000, which is option B. So question C is a bit indirect. Is saying which number of offloading teams results in the lowest total expected cost. So we already looked for total expected cost, and we have 132,500, 17,000, 77,500, 66,000. So which one was the lowest? Which one was the lowest total cost? It was 17,000, and 17,000 was value K, and from our question, the value K was under 2 teams. Value K was under 2 teams. So the team that the number of loading teams that resulted in lowest total expected cost is 2 teams. So the answer here is B. Question 7 says, if the company wants to minimize waiting costs only, which number of offloading teams should it choose? So it means you want the least waiting cost, and the least waiting cost is 48,000, and is obtained by using 4 teams. So it use 4 teams, which is option D. So question 8 says which number of teams has the highest total salary cost? And if we come from the table, the salary is provided on this column 6, and team 1, the salary is 4,500, 2 teams is 9,000, 3 teams is 13,500, and 4 teams is 18,000. So the teams with the highest salary is 4 teams, which is 18,000. Yes, so from our question, the option will be C. The number of teams that has highest total salary cost is 4 teams. Question 9 is direct. What is the value of K? And we calculated for the value of K, and the value of K is 89,000. 89,000, which is option A. Be careful because you see option A and B are somehow confusing, but the answer is 89,000, which is A. Question 10 says find the percentage reduction in truck hours lost when moving from 1 to 2 offloading teams. Percentage reduction in truck hours lost when moving from 1 to 2 offloading team. So the formula to calculate for that percentage: total truck hours when using 1 team minus total truck hours when using 2 teams over total truck hours when using 1 team. Total truck hours for using 1 team was 64, and for using 2 teams was 40 hours. So it will be 64 minus 40 over 64 times 100. That will give you an answer in percentage. So here you get 24 over 64 times 100%. So that will be equal to 37.5%, and this is approximately 38%. So from our multiple choice, our answer was 38%. Yes. So if you are given 38% or 37.5, that should be your percentage reduction from moving and from using one team to two teams. Question 11 says, if the cost per hour of idle track time increased to 2,500 cedis, the waiting cost for 3 offloading teams will be. So remember the formula for waiting cost is total track hours lost per shift times cost per hour of idle track time. And the total track hours lost per shift, we had the value already, and for 3 teams it was 32 hours. So it will be 32 hours times the cost per hour of idle track time. So before it was changed to 2,500, it was 2,000, but now the value or the cost per hour of idle track is 2,500. So that will give us our new waiting cost for 3 offloading teams. So 80,000. And this is option A. So our value will be 80,000 cedis. That will be our cost. So question 12 says the ratio of waiting costs to service cost for one offloading item is. So to get the ratio of a waiting cost and service cost is like taking waiting cost over service cost. And for this for team 1, our waiting cost was 128,000 cedis. So it will be 128,000 cedis over the service cost. The service cost from the table for team 1, offloading team salary of service cost, it was 4,500. So it's 128,000 over 4,500. So that will give us 28.44. Answer will be equal to 28.4, which is approximately to 28. So from our answers, our option will be option A, which is 28:1. 28:1. So that should be our answer for this question. Question 14 says, if the company shift from 2 to 3 teams, the reduction in waiting cost is. So we are looking for the reduction of waiting cost if the company starts using team 3 from using team 2. So we had the waiting cost here, and when the company was using team 2, the waiting cost was 80,000, but when it went to use team 3, the waiting cost was 64,000. So to get the difference, we'll take 80,000 minus 64,000. So the difference will be 80,000 minus 64,000, and that will give us that will give us 16,000. So this is the reduction from using 2 teams to 3 teams, and that is option A. Question 13 says, which scenario has the smallest difference between waiting cost and service cost? So we are looking at the teams. We are given the waiting cost and the service cost. So let's go back to the question. So for team 1, the waiting cost was E and the service cost was 4,500. So we want to know the difference between E and 4,500, and we established that the value of E is 128,000. So the difference will be 128,000 minus the service cost, which is 4,500. We go again to team 2. For team 2, the waiting cost for team 2 was 80,000. And their service cost was 9,000. So it's 80,000 minus 9,000. Okay. For team 3, their waiting cost was 64,000, and also their service cost was 13,500. So it will be 64,000 minus 13,500. For team 4, the waiting cost was 48,000, and the service cost, it was given in the question, which was 18,000. So let's calculate to see which one has the smallest difference between waiting cost and service cost. So plug in the values in the calculator for team 1, 2, 3, and 4. Upon solving our values, we get the difference in team 1 is as shown there, in team 2 71,000, team 3 and team 4. So the one that had the smallest difference was team 4. So from our question, the answer is D, team 4, or 4 teams. In team 3 from using team 2. So we had the waiting cost here, and when the company was using team 2, the waiting cost was 80,000, but when it went to use team 3, the waiting cost was 64,000. So to get the difference, we'll take 80,000 minus 64 and 80,000 minus 64,000, and that will give us to give us 16,000. So this is the reduction from using 2 teams to 3 teams, and that is option A. Question 15. The total cost saving when moving from 1 to 3 teams is closest to when moving from 1 to 3. So we are looking at the total cost. Remember, when we are using one team and when we are using 3 teams, the cost will be different. Yes. So when we are using one team, our cost was 132,500. But when we are using 4 teams, our cost was 7,500. So what's the difference? It will be 132,500 minus 77,500. So our cost here will be 55,000. But from the question they said the total cost saving when moving from 1 to 3 teams is closest to. So our answer was 55,000, but as we see from the question, there's no 55,000. But the value that is close to 55,000 is 52,000. So we'll go for option D. Yes, so our answer is 52,000. So for question 16, it asks the average waiting time per track for one offloading team is. So these values were given in the question already. So the average number of tracks, average time each track waits to be unloaded for one team is 8 hours. 8 hours. Yes, so we are going back to our question, and the answer is B, 8 hours. So 17th question asks, how much service cost would the company pay when they service 4 teams? So they are asking for the service cost, but in our question we were not supposed to calculate for the service cost as it was fixed and it was given. So this is the offloading team salary or service cost, but we are asked for 4 teams. So our service cost was 18,000. So going back to our question, the value is 18,000. It's given here in option B. So question 18 asks for 4 teams the track hours lost is, we calculated for this value already. Yes, so we calculated here track hours lost per shift, and when they were using 4 teams they lost 24 hours in total. So the answer here is 24 hours, which is option B. So question 19 asks that the reduction in average waiting time from 1 team to 4 team. So how much will the average waiting time be reduced if you move from using 1 team to using 4 teams? So we are looking at the waiting time. So let's go back to our table, and from our table the waiting times they are given here in row 2, and we see like for using 1 team the waiting time is 8 hours, but when we go to use 4 teams the waiting time is 3 hours. So the difference or the time reduction from using 1 team to 4 teams, it will be 8 minus 3, which is 5 hours. Yes, so it will be 5 hours, which is option A. So our last question for this queuing theory, it states that if the number of arriving trucks increases to 10 while keeping waiting times the same, the track hours lost for 2 offloading teams would be. Yes, so let's go back to our question. Before this change, the average number of trucks arriving was 8. Yes, but now is 10. So it's asking the value for value of B, because we are looking at the total track hours lost per shift when using 2 teams. So we are looking for B when the value here is 10. So to get the value of B, it will be equal to 10 times 5. 10 times 5. So the value of B here will be equal to 50. Yes, so checking from our option, the value will be equal to 50 hours. So when the number of trucks arrives change to 10 while the waiting time is the same, and the waiting time was 5 hours, the value here will be equal to 10 times 5, which is 50 hours. Thank you so much. I hope you've understood, and stay tuned for our next videos. Bye.